Good morning, students. The last period we have discussed binary operations, defined binary operations, and properties of binary operations, the closure law, commutative law, not closure law, commutative, associative, and inverse, and identity. Okay? Even some problems also I solved. I will continue today with binary operations. Determine whether star is a binary operation, commutative, or associative, commutative or associative, on Z plus defined by A star B equal to 2 to the power AB for all AB belongs to Z plus. Determine whether star is a binary operation, commutative or associative, and star is defined A star B is 2 to the power AB. So what is the first one? Commutative. Whether it is commutative or not, okay, we check. For all the AB belongs to Z plus, such that A star B equal to B star A. A star B equal to B. This is a commutative formula. But how to prove how to prove that commutative both sides are equal? A star B 2 to the power AB, A star B. B star A 2 to the power B, 2 to the power AB, and BA is same as AB, 2 to the power AB. So LHS equal to RHS. Therefore, star is commutative. Star is commutative on Z plus. Now it is commutative. That was comparing. Both are equal, but this number is not belongs to Z. It's also positive. Okay. So what is the next? Associative. Whether it is associative or not, it is present star is commutative. Okay. Both are equal. Now what is the second one? Associative. Okay. Associative property. For all ABC belongs to Z plus. In associative, have to select 3 elements. Now what is the formula? Such that A star B star C, A star of B star C. This is the associative property. So this associative property equal you have to prove whether it is equal or not. Let us take LHS A star B star C, A star B 2 to the power AB, because it is given star is defined A star B 2 to the power AB star C. Now I am taking X star Y, X star C. What is X? 2 to the power AB. So 2 to the power AB is X I am taking. 2 to the power X into C. So 2 to the power X value, 2 to the power AB into C. This is the LHS. What is the left side? 2 to the power 2 raised to AB into C. See whether it is RHS equal or not. A star of B star C. A star, what is that? B star C according to star is defined. B 2 to the power A, 2 to the power BC. A star y. What is the y value? 2 to the power bc. 2 to the power ay. 2 to the power a at it is. What is the y value? 2 to the power bc. Here 2 to the power 2 raised to ab into c. Here 2 to the power a into b is not equal. So LHS not equal to RHS. Therefore, star is not associative. So this problem commutative but not associative. See, this question is asked in multiple choice also. There is no difference multiple and subject. He made theory question C, CET question made theory. Okay. The same question in CET options, correct option is star is commutative, but star is not associative. You know how to prove it? The calculation part is very simple. Even I am taking this without x also you can do. This next on z a star b e to the power b. Same sentence, like whether star is commutative or associative. Now z plus a star b, a raised to b. Now commutative, a star b equal to b star a. It is a property. A raised to b, b raised to a. I think not equal. A raised to b not equal to b star a. So this problem is not commutative. A to the power b not equal to b to the power a. So this is not commutative. Now whether it is associative, a star b star c, a star of b star c. What is a star b? A raised to b star c, a star b to the power c. What is the difference? A star b, a to the power. This base में रहेगा, a power में रहेगा. ये base में रहेगा. A raised to, this is base, 4 raised to. But this is 4 raised to what? C. And a raised to b raised to c. Even if a raised to bc, a raised to b raised to c, I think this also not equal. So a star b, a to the power b, this is neither commutative nor associative. Okay? No commutative, no associative. This I can explain directly, but you only have to write your notes. So it's orally I am explaining. Okay? So a raised to b neither commutative nor associative. Not equal. Okay? On z plus on r other than 1, a star b equal to a by b plus 1. A by b plus 1. What is for all a b belong r other than 1? A b other than 1. So, for all a b belongs to r other than 1. Solution commutative. Commutative. What is the formula? For all a b belongs to r other than 1. A star b such that a star b equal to b star a. A star b, a by b plus 1, b star a, b by a plus 1. A star b, a by b plus 1. B star, what is b star a? B this divided by this plus 1. B divided by A plus 1. A divided by B plus 1. And if LHS not equal to RHS. Therefore, star is not commutative. Star is not commutative on R. Understood is other than 1. See whether it's associative property or not. So it is very simple. Even if you have read it at LHS and RHS, better associative, better you should take LHS separate and RHS separate. Now whether it's associative property or not. Okay, you need to check. Number 2, associative property. Associative. For all ABC belongs to R other than 1. But real number other than 1. Such that A star B star C, favorite A star of B star C. Now actually it is other than minus 1. You want to take the previous other than minus 1. A star B, A by B plus 1 for all A B belongs to R other than minus 1. Okay? So LHS A star B star C. What is A star B? A by B plus 1. Star C. You take X star C. What is X value? A by B plus 1. And commutative are given AB belongs to R other than, but not other than 1. Just to remember, just note, make it correction. R other than minus 1. So what is A star B? A by B plus 1. What is X star C? X divided by C plus 1. X divided by C plus 1. X value A by B plus 1. 4 divided by C plus 1. So A by multiply these two B plus 1 into C plus 1. So this is left side. What is the left side answer? A by B plus 1 into C plus 1. Now whether RHS equal to A star B star C. A star, what is the B star? B by C plus 1. Now A star Y. So what is the Y value? B by C plus 1. What is A star Y? A star Y. A star Y. A by Y plus 1. A by, what is the Y value? B by C plus 1 plus 1. And take LCM A into C plus 1 by B plus C plus 1. So LHS not equal to RHS. Therefore, star is not associative. Star is not associative. So this problem also neither commutative nor associative. So A star B not equal to B star and A star of B star C not equal to A star B. Okay, this is neither or. Very simple, just only X or Y taking, but not equal, okay? And what is the next problem? Right. Even this problem, A star B, A plus B plus AB, A star B equal to A plus B minus A. These two problems are both commutative and associative. Problem is not equal, I am telling you. A star B, A plus B plus AB, and A star B, A plus B minus AB. These two problems, just you have to practice these two and note these two problems and practice whether it is commutative. Commutative is where I am telling very simple. Associative, better I have. Even associative also I explain the easy method. One x, one y. Okay. So A plus B plus AB, A plus B minus AB. You remember these two always commutative and associative. Rational number. It depends on how set the n is. Right. On the set Z, next problem. On the set Z, star is defined as A star B equal to A plus B plus 10. For all AB belongs to Z, find the identity element. Find the identity element and find the inverse of first star. Very simple. Even this problem A plus B plus 10, A plus B plus AB, A plus B minus AB always commutative and associative. Even this problem A plus B plus 10 always commutative and associative. But already problems are explained commutative associative how to solve it. But now it is different question. Find the identity and inverse. How to find the identity, how to find the inverse. Okay? Now start A star B equal to A plus B plus 10. You know what is the A and B? A and B both are two teachers. Now what is the first one? Identity. What do you write? Identity law. Identity law. Identity law is very simple. A star E star A. Now A star E equal to E star A equal to E. But last the previous class I explained. In both cases, identity element must be same. Identity element must be same. That must be belongs to Z. Same, but must be belongs to Z. So different means it is okay, no problem. So not identity satisfied. Not does not exist. Now A star E equal to E first, and E star E equal to E. A plus E plus 10 and E plus A plus 10. So A cancel, E is minus 10 and E is minus 10. Therefore, E equal to minus 10 belongs to Z is the identity element. Is the identity element on Z only. So both cases are saying E equal to minus 10. That this number must be belongs to Z. Sometimes both are different, sometimes both are equal. This number, suppose instead of minus 10, 1 by minus 10, minus 1 by 10 does not belongs to Z. So identity. Okay. Be repeating once again, students. Don't confuse. Both identity are same. In both cases, identity say that number belongs to Z. When both are different, clearly it is identity does not exist. So what is the identity element in this problem? Minus 10. Okay? Minus 10. Even oral questions, you practice problems, you mix practice once, twice, thrice. Even answer also we are hiding. No problem. One problem we are repeating 4 or 5 times. Okay, now इसको answer भी मालूम होते क्या है. But we will get good marks in C, multiple choice in C, because some in C it is questions so lengthy. Even it takes 5 minutes, 6 minutes, 10 minutes also. That already the problems are practicing theory only get 2-3 times. Answer समझ कर answer मालूम रहता है. So जा सकते हैं. So A plus B plus 10. A plus 10 है ना, minus 10 is the identity. Opposite. Even minus 10 plus 10 is the identity. In generally, A plus B plus n equal to minus n. Minus n equal to plus. This be careful. A plus B plus 2021 and minus 2021 is opposite identity. Now what is the question? Next question, inverse. Inverse law. What is inverse law? A star, A inverse equal to, how is A star, A inverse star equal to? A plus A inverse. A plus A inverse plus 10 equal to minus 10. A plus A inverse equal to minus 20. Minus 10 minus 20. A inverse equal to minus 20 minus. So this is general formula. In this problem, this is the general only. But you are asking inverse of what? Put A equal to 4. 4 inverse equal to minus 20 minus 4. 4 inverse equal to minus 24. Therefore, the inverse of 4 is minus 24. Okay? But in C, the inverse of this, in this problem, what is the inverse of 4? So answer is minus 24. In general, what is A inverse is minus 20 minus. It is not given, only find the inverse. Number is not given. Only find the inverse. Find the inverse. A inverse with A raised to minus 20 minus. Okay? This is important problem. So all the problems you know that how to solve commutative, how to solve associative, how to solve identity, how to solve inverse. Okay? Even problem one more, it's the old question I explained. A star B equal to AB by 5. For all AB belongs to Q plus. What is the Q plus? Set of rational numbers. A star B equal to AB by 5. For all AB belongs to Q plus. My question. This problem, all the properties 4 properties satisfied. Even you take commutative equal, associative also equal, satisfied. Even identity is also. Identity is very simple. A star E star A equal to A star E by 5 equal to A, and E star A by 5 equal to A. Now cancel, A cancel, E equal to 5 and E equal to 5. So it must be belongs to Q plus. So what is the identity element here? 5. You remember, this is the identity element. So AB by N is the identity element. Okay? A star B AB by 5 for all AB belongs to Z plus. So 5 is the identity. So even minus is comes, minus is not because it is Q plus. When you got minus, identity does not exist. Given this problem, inverse also satisfied. A star A inverse equal to E. A into A inverse by 5 equal to, what is the identity element? 5. So what is the inverse? 25 by 5, 25 by 3. So this is the inverse. A inverse is equal to 25 by A. Suppose question only inverse. Find the inverse of 20. So put A is 20, 25 by 20. Find the inverse of 3. Put A is 3, 25 by 3. So this is the general formula. Inverse. This is the inverse. A inverse is 20 in general. So this problem, commutative, associative, identity, and inverse also exist. Even A star B, 2A by 3. Main question, commutative, same for all AB belongs to Z plus. For all AB belongs to Q plus. Easily commutative, yes commutative. And associative also satisfied. Identity important, not 3. So these are told 3 by denominator number is identity, denominator number is, but here AB is there. So AB rena A2 is comes in denominator, yes. So 3 by 2 is the identity unit. That is correct. There is no coefficient of AB. A into AB rena, but इसका क्या रहता है इसको देना, इसको नीचे लेना तो 3 by 2. Now it is 3 by 2 is the identity. Okay. And this also 2A by 3 identity. Even that first option 3 रहते हैं. So most of the first option is डालते हैं. So 2 by 3, 3 by 2 is the identity. ठीक लेना. So AB by N. You won't just go to really get problems and write. Okay. This is not very difficult problems of binary operation. Okay. Let's start with the next example. Let star be a binary operation on N given by A star B equal to LCM of 5 and 7, LCM of A and B. So star is defined A star B equal to LCM of A and B. Find 5 star 7 and 20 star 60. 20 star 60. So what is the question is asking? Given is what? LCM of A. So he is asking LCM 5 and 7, LCM of 20 and 60. Least common multiple. Least common multiple. Now what is A star B equal to LCM of A and B. What is the first question? 5 star 7. So LCM of 5 and 7 is slightly rougher solve that. 5 and 5 7. So what is the answer? 35. ये प्रॉब्लम कैसे स्टूडेंट्स को समझ में नहीं है तो भी आंसर ले सकते लिख सकते because students also they don't know the LCM, just they are multiplying. Even you get marks, but mostly in 2020 this same question. LCM is the only question. 5 into 7, very simple question 35. And same for procedure they are following here. 20 into 3 0 like that. 16 into 33 20 लिखते okay ये दोनों मल्टीप्लाई करो तो ये आ रहे हैं but इधर नहीं आते इधर फैक्टर्स आर कम्स okay so anyhow 5 into like students select रहे तो ये स्टार 5 के साथ just by multiply but इधर multiply नहीं आते ना so what is the LCM 5 star 7 is 35%. So what is the 20 and 16? Second problem is 20 star 16 equals to LCM of 20 and 16. Rough work 60, 20, 4, 4, 4, 4, 5, 4, 1, 4, 5, 5, 1. So I think it is 16, 80. 80 is the answer. Okay? 80. What is the 20 star 16? 80. In the LCM of 20 and 60. Okay? Even this problem HCF, HCF is highest common factor. A 5 into 1, 7 into 1. LCM is all, right? Just I'm explaining HCF. 5 into 1, 7 into 7 into 1. 1 is the common, A is highest common factor. I think what is the HCF for 5 and 7 is 1 only. So either HCF 60, 20 and 16 is very short method. How to find the HCF of two numbers? You go to divide system. A non-zero remainder. कब तक लिखना बोले तो रिमाइंडर 0 तक सॉल्व करना है. For example, small number 16 and 20 ऐसा रखें. You are there to 12th standard in high school steps is the need. And high school में step नहीं लिखे तो marks नहीं देते. But इधर क्या है? You can write any method. But 12th standard students can write any other higher level also no problem. 16, 1 is 16, a 4 applied, 4 divides 16, 4 4 is 16. So what? Still the remainder is 0. A divide system करके remainder 0 आना तक लिखना है. But the previous number क्या है? 4. That 4 is non-zero remainder is called HCF. ये 0 आता है ना? ये 0 तो previous remainder देखे तो each number remainder होते हैं. Non-zero remainder is called HCF. Okay, be careful. But problems are not giving. Just for both together, I am explaining HCF and LCM. So 69. So what is the LCM of 20 and 60? 80 are. HCF क्या रहा तो 16 divided 20. Still the remainder is 0. The non-zero remainder is called HCF. Okay. Even this problem. 5 and 7, okay, 5. So practice is lower class numbers. If I divide 7, 5 and 5, 8 to आता, 8 2 divides 5, 2 to the 4 आता है, 1. Next 1 divides 1 into 2, 0. 0 is the remainder. I told how to finding HCF of two numbers, still the remainder 0. The non-zero remainder is called an HCF. So 1 is 5 and 7 HCF is 1. Is next problem. Is a star defined on the set. Defined on the set. 1, 2, 3, 4, 5. By A star B equal to LCM of A and B. If the star is defined on the set and defined is what A star B equal to LCM of A and B. So justify your answer. Whether this problem star is binary operation or not. So very important. Usually in binary operation, the given set is finite. the given set is finite means, and you go through the table only, we can produce the table for this set. When set is finite through a table, that operation is called operation table. Repeating once again, what is the operation table? The given set is finite through a table, that is called operation table. Okay, you will take what is given. I am taking this set in 1, 2, 3, 4, 5. Take any set, but it is not given. Operation table. Be careful, just to concentrate here. 1, 2, 3, 4, and 5. 1 row as well as column. 2, 3, 4. Then 5. The name is called operation table. Students ask me, sir, what about this side? The operation may be addition or subtraction. Suppose sometimes addition is asking plus link, multiplication asking multiplication. Then what is this is? LCM of these two. A star B, LCM of A. Now what is LCM? 1 and 1 LCM is 1. 1, 2, 3, 4, 5. 2 into 1, 2. What is the LCM of 2 into 2? LCM of LCM of 2 and 2 is LCM of 2 and 1. What is LCM of 2? 2 1 is 2. LCM is 6. But 6. Okay. So my question, whether it is star in binary operation or not. Whether star in binary operation or not. 2 into 3, what is the LCM of? So A star B equal to LCM of A and B. So I am taking one example, 2 star B I am taking LCM of 2 and 3. Okay. What is LCM of 2 and 3? Just 6 only. So this is 6. Either you take 2 into 3, 3 into 2, no problem. 2 into 3 is this number. So 6 does not belong to set A. Does not belong to set A. Therefore, star is not a binary operation. On A, star is sometimes the one last question. Question you read carefully. Is the star is defined on the set LCM of A? सबको नहीं लिखना। अब दैट वन मार्क्स क्वेश्चन है, इसको सब लिखे तो 2 मार्क्स 3 मार्क्स भी लेते स्टूडेंट्स। You go to 2 into 3, 6 enough. And go 2 into 3 or 3 into 2. 2 into 3, how much it is from 6 are there. 2 into 3, LCM 6, but 6 does not belong to set A. All the entries belongs to set A. That is called binary operation. What is the binary operation? ये टेबल में कितना डिजिट्स आता है, नंबर्स आता है, ये सेट में रहेगा. That is called binary operation. But 6 is all the entries belongs to set A. That binary 6 does not belongs to set A. So this is star is not binary operation in this. So this is good example. Okay. So, what is the binary operation table? Operation table is when you are taking the table, the given set A is finite. The given set A is finite. How to solve? Through the table. The table is called operation table. Operation table will be plus or minus. But इधर LCM पूछे ना, LCM of 26 बोले तो सेट में नहीं रहता ना, रहना है तो बाइनरी ऑपरेशन सब एंट्रीज टेबल में एंट्रीज all entries on the table are belongs to set A. So that is called binary operation. Okay. So maybe this is the second period. One more period is need the binary operation. Then I'll start some multiple choice questions that I may explain in the previous problems, relations and functions, binary operations. On 60 questions I discussed, it's multiple choice. See, tomorrow we'll continue with the binary operation. Still some important problems are there. Thank you.